Hello, in this section 12.5, we are going to learn how to find the line and the planes in space by using the vector method. So the first part we're going to do is called line and line segment. So firstly, I'm going to draw the graph to you and let you have some idea how do we develop, how do we get the equations for the line and line segment. So let's see, the first part is line and the line segment. Okay, so actually we are going to do in the 3D because actually by using the vectors we can do the same method in 4D, 5D, any dimensional space. So here we just say, for example, 3-dimensional space. Okay, we draw the XYZ coordinate, and then if we want to find a line passes through a point which is given by this one, okay, pass P naught, and with direction, the direction is given, so which is same as the direction of a vector v. We want to find the line equation. So let's see, we want to find a line parallel to the v vector, so same direction, right? So it should be parallel. So now let's draw the line. Okay, we're looking for this line. And right now, we choose any point in the line. We say that is P, and we give its coordinate x, y, z. Okay, and by using those 2 points, we can make a vector P not P, right? This vector, and we know this vector should be parallel to the v vector because it's in the same direction as v vector. So now let's write down this way. How do you find the given 2 points? How do you find the vector P naught P? So we know we use the terminal point minus initial point, so it should be x minus x naught, y minus y naught, right? And z minus z naught. And this vector is parallel to the v vector. So if the v vector is given by v1, v2, v3, they are parallel. They may have different lengths, but they are in the same direction. So here we should say this is cos t times that. T is can be anything. Okay, t can be anything. So it's kind of like a proportional to the v vector. So now let's see. And if we simplify the right side, distribute the v into like a multiple by the scalar, kind of like t, so become tv1, tv2, tv3. Okay. And now we get 2 vectors, so left side equals the right side. So for each component should equal to each other. That means x minus x naught equals tv1, y minus y naught equals tv2, z minus z naught equals tv3, because those 2 vectors need to be equal to each other, right? So we can write down this naught equals tv1, y minus y naught equals tv2, z minus z naught equals tv3, and x, y, z is the unknown because we're looking for the line, and then x, y, z can be any point in the line. So we want to write down this as equation of x, y, z. Okay, solve them. So x equals x naught plus tv1, y naught plus tv2, z naught equals tv3. And this is called, you can see this is same as x equals ft, y equals gt, z equals ht, something like that. T, x naught, y naught, z naught is given, v1, v2, v3 given, so only the t is unknown, right? So you can say that's parameter. This is same as chapter 12.1 at the beginning. We learned like a parametric equations. So actually this is like a kind of like a ft, and second y equals gt, z equals ht, and then this is the parametric equations. Those parametric equations give us the line for the line give us the line that passes through the point and has the same direction as v vector. Okay, so there is also another way to write down the line equation. So that the other way is called the vector equation for the line. Let's take a look. Right now, if I write down them as vector way, so it's like if I write down x, y, z as, so we can say x naught plus tv1. Okay. The second component y naught plus tv2. And the third component should be z naught plus tv3. Right, so this is a vector way. And for the right side of the equation, we separate this vector into the sum of two vectors. So y naught, z naught plus, you can see, separate this into two pieces, tv1, tv2, tv3. And then we rewrite this plus factor the t out because it's like a scalar, v1, v2, v3. And then now this is, we write x, y, z as the vector rt, and this vector we write down as r naught, x naught, y naught, z naught as the vector r naught, and plus t, and the direction is called the v vector. So this is called the vector equation for the line. Vector equation for the line. So there are two kind of equations. And also for the vector equation for the line, I can show you in the graph what's the meaning of that one. Let's do 3D x, y, z. Now let's take a look. Before we have a p naught, right? And we know the direction. And then we say here's a p, which is x, y, z. And then right now we call the OP vector, we call that is r naught vector. Okay, r naught vector. And plus p naught p vector. That vector is parallel to the given v vector, so it should be tv vector, and equals the sum op vector. Op vector, which is the r vector. So we say this is rt. So I can show you in the color pencil. So rt is the right color. Okay. And that means rt is our line equation, which equals the sum of those two blue vectors. Okay. Sum of the two blue vectors. So you can use any method to find the line equation. It doesn't matter. They mean the same thing. In calculus 4, you're going to do a lot of line equation because you will find the tangent line in 3D. Okay. Now let's take a look at the example. Find the parametrization for the line through a point parallel to a given vector. That means the point P naught is given and parallel to this vector, which is 2i plus 4j minus 2k. Okay, so actually for this kind of problem, it's pretty easy. We can write down the parametrization directly by using the formula. So x equals x naught. X naught is -2. And plus tv1, v1 is 2. And you can also write down the v vector as this way. Okay. And the v1 is 2, so 2t. And the y naught is 0 plus v2, 4t. Z equals z naught, 4 plus v3t, so minus 2t. And if we simplify, so it just x equals -2 plus 2t, y equals just 4t, z equals 4 minus 2t. Okay, that's the parametric equation line. Parametric equation for the line. Now we can try the exercise. The point is given by this one, parallel to I plus 4j minus 2k. Pretty easy one, so I'm going to give the solution. You can check this yours. Like this, right? Okay, now let's take a look at another example. Find the parametric equation pass through two points. The 2 points are given by this. We see this P and Q, which is 1, 1914. So actually we did this kind of problem in 12.1. What we did, by using those 2 points, we find the slope, right? Actually our problem, the quiz problem, is in 2D. In 3D we don't know actually. We find the slope, and we write down our y minus point slope equation, and we say this is t, and solve for y. That's the quiz problem, right? And then now we, with the vectors, we can find the equation pretty easy. We don't have to do that way. So you can see here, let's draw the graph P and Q. Okay. This problem is different from the example 1. Example 1, the direction v vector is given. Here we don't have the v vector, but we can find the v vector by ourselves, right? So the line passes through those 2 points. So this line, the direction is same as the PQ vector. Is that correct? So we can just use this way to find our direction vector. So PQ vector equals Q point minus P point, terminal minus initial point, which is 1 minus negative 3. 4, negative 1 minus 2, negative 3, 4 minus negative 3, 7. So this is our direction. And the next, you can choose either X point, the point P or Q. Doesn't matter too much for your point. So if I chose the P, so it should be negative 3 plus 4t, 2 minus 3t, and then negative 3 plus 7t. Right? So here I choose the point P. If you choose point Q, it's also okay. You can choose P or Q. Also, you can also make your direction QP. Doesn't matter, because here we just need to find the line equation. Okay, which direction doesn't matter. Now let's try this exercise. Okay, so I'm going to write down the answer. So if here I choose the point P, so and next I find the direction. So minus 2t, and plus 2t. So here my direction is PQ vector. I use the Q point minus P point. Next one example is totally similar to the example 2, but we are not going to find the line. So for the line, actually t can be from negative infinity to infinity because the points can be anywhere, right? But here, example 3, we want to find line segment. Through the same points, okay, same points. So we do need to find those again, same as example 2. and Q 1, negative 1, 4. So same thing here. We skip the parametric equation. We just copy them. Parametric equation. So the only difference is here, line segment. Okay, line segment. So we have boundary for t. Same as the quiz we did before. We need to find the boundaries. We need to find the boundaries for t, and how to find that? Let's take a look at how we set up the line. So line segment means all the points in the line has to be inside the PQ, right? Has to be there. So if the point is same as P, that means what? That means t equals 0, because our vector, so our r vector equals r0 plus t v vector, and the v vector is the PQ vector. Okay, so when the point is same as that one, that means t equals 0. And if the point is as q, so you can see that means t equals what? T equals 1. And it cannot go outside. Okay, this has to be inside the p and the q. So that means t from 0 to 1. So whenever we set up the parametric equation by using this way, so our t is always from 0 to 1. Now we are going to learn the second part, so which is the distance from a point to a line. So if we draw graph, it looks like this. So we have a point and we have a line, and the line is given by the parametric equation. That means we have the direction of vector v, and we have already, so from the line equation we can see which point. For example, if our line is given by that one, 5 minus 2t. So from here we can tell what information we can tell. We can tell this line passed through the point 1, 0, 5, right? And with the direction 2, 3, negative 2. Okay, so for a given line, we know the point and then we know the direction. And then right now we have another point. So we want to find the distance. Okay, distance is like here, d. And if we draw perpendicular line to the given line, so the distance is just like this. So how to find this distance? We are going to use the vector method. So let's take a look. I'm going to connect P and S. We make a new vector. Okay, so here the vector is PS vector, right? And the length is that one. And here the angle is theta. So let's take a look. Actually, the distance equals what? The PS vector length times sine theta, opposite, right? Sine theta. So how to find the distance? Actually, the distance is PS length times sine theta. But you know theta, we don't know what is theta. Theta is the angle between the vector PS and the vector V. But we already learned dot product and the cross product, and used to remember which product has the sign. Actually, it's cross product. So have a quick review. U cross V, the length equals U length, V length times sine theta, right? Actually, another definition for the cross product is given by this one, U, V, sine, and n vector. But if we take the length, equals the U length, V length, sine theta. So here we are going to times the length of V and divide by length of V, because we want to make this into, cross product length. So this becomes, the numerator becomes what? Becomes PS vector cross V vector and take the length. So this is the formula how we find the distance from a point to a given line. Now let me show you the example. Example 3, example 4 actually. So find the distance from a point 1, 1, 5 to the line. The line is given by this one, parametric equations, 1 plus t, y equals 3 minus t, z equals 2t. Okay, so firstly, we know the point P should be 1, 3, 0. From the parametric equations, we can see the line pass through this point, right? And with the direction v equals 1. So direction of the line should be 1, 91, 2. And then now we can make a vector like PS, so SP, right? And then we do dot product with the V vector. So PS vector equals S minus P. So S is given here and P is 1, 3, 0. So 1 minus 1, so it should be 0. Okay, it's going to be a vector. 1 minus 3, negative 2. 5 minus 0, 5. So this is the vector PS. Next step, we want to find the cross product PS and V. And the other doesn't matter. You can also do V cross PS because later we just needed the length, magnitude, right? So it doesn't matter which cross which one first. So the cross product calculation, IJK, PS second row, V vector third row. Okay, so we just calculate this cross product and we skip the calculation. So it's I. Actually, for the i's component, you can have a quick review. Negative 4 minus negative 5. So negative 4 plus 5 should be 1. So should be I. And 5j plus 2k. Okay, so this is the cross product. For the distance, what do we need? We need the length of this vector. So length of that one is 1 plus 25 plus 4. So it should be root of 30. Okay, and next we also need a v length. So which is square root of 1 plus 1 plus 4. So which is root 6. So the final answer distance is the length of PS cross V divided by length of V. So which is this one. So final answer is root of 5. So that is the distance. And here we can try the exercise. We want to find the distance from this point to this line. Y equals 5 plus 40. 40. Z equals negative 3 minus 5t. Okay, so you can try this. I can give you the solution later. So here's the solution for the exercise problem. The distance is root of 90, and after simplify, it is 3 root 10. Okay, the next one topic we are going to learn is the equation for the plane. Equation for a plane. Okay, so we are going to find a plane equation. So firstly, for the plane equation, we know n vector. So n vector is called a normal vector. I'm going to show you what's the meaning of this one. Okay, CK. And in another way, you can write down this as capital A, B, C. Right, this is vector. So it's like here. If we know normal vector, so normal vector is the vector perpendicular to the plane. Okay, normal vector. So this is called normal. And we know a point, any point in the plane. So it's kind of like the point can decide where's the plane, and the normal vector can decide what's the angle or direction of the plane. Okay, so if given the normal vector, given a point, we can fix the plane and we can find the plane equation. And we're going to do this way. So we just, we can suppose P, like any point, pick any point in the plane. We say just x, y, z. X, Y, Z. The point can be anywhere. You want to draw anywhere, you can draw anywhere. So I just draw this way, okay? And we know the n vector is orthogonal or perpendicular to the plane. So this one, n vector is perpendicular to any vector in the plane. So n vector is also perpendicular to the P naught P vector. P naught P vector, right? So, and we know if they are perpendicular, so we can just write down, for the perpendicular vectors, there is a property. The angle is 90, so we learned the dot product between those two should be 0, right? So by doing this way, we can find the equation for the plane. So let's see, I'm going to write down this one. A, B, C dot P naught P, which is x minus x naught, terminal point minus initial point, equals 0. And if we calculate the dot product calculation, A times x minus x naught plus B, y minus y naught plus C, Z minus Z naught equals 0. So this is the plane equation, okay, actually. And then next, I'm going to give you the definition for the normal vector, okay, just official definition. So the orthogonal vector is also called a normal vector. That's why we always choose n. That's the first letter of normal. Okay, so usually we write this as n vector. So with our plane equation, so the plane through a point, the point is P naught, which is x naught, y naught, z naught, okay, normal to a given vector, which is A, B, C, okay, has the vector equation. So vector equation, that means n dot P naught P vector equals 0. And the component equation, means if we expand the vector equation, that is A times x minus x naught plus B, y minus y naught plus C, z minus z naught equals 0. Okay, and we also have a component equation simplified, so it's called component equation simplified, or simplified component equation, or sometimes we call that general equation. Component equation, okay, that means we expand every terms, and we leave ax plus by plus cz at the left side, and move everything to the right side, and combine all the constants together, which is d. Okay, so this is called the simplified component equation, or general equation. Now let's take a look at example 5. Find an equation for the plane through a given point with the normal vector. So actually, we just need to write down the equation directly. So capital ABC, there are 2, 3, and 4. So it's going to be 2, x minus 2, plus 3, y minus y naught, which is 4, and plus 4 times z minus -1, so plus 1 equals 0, right? So this is just the plane equation. You don't have to simplify. So, but here I want to show you what the general form look like. So if we simplify this equation, we can get this equals 12. And this is called simplified component equation or general equation, so you can see. But you don't have to. Exercise. Given a plane through this point, perpendicular to this plane, and vector. Okay, like this. So we can just write down the answer directly. Same thing. And the vector, I like to write down this way. 5, 2, -1. So it's not easy to make mistake. And we just write down the equation as 5x plus 3 plus b, which is 2, y minus 0, right? And minus, so actually plus c, so which is minus 1. And here z minus 7 equals 0. So that's the answer. And for the plane equation, we can stop here. And the next class, we are going to find a plane pass through 3 points. So given any 3 points, we can fix a plane, right? So next class, we're going to do this one, this